I am Amitabh Sinha, and I welcome you to this online event, which is part of our online series of explained events, where we try to deep dive into the pressing issues of our times. Also, get our experts to try to, and answer some of the questions that have been occupying us. It's also a sort of an extension to the explained section that is there in the newspaper, also on the Indian Express online. Uh, so for today's event, as you know, we have invited Dr. R. Krishnan, who is the director of Pune-based Indian Institute of Tropical Meteorology, IITM. He is a climate change expert. IITM is also that's the premier research institution which does scientific research into meteorology, into climate change, and related issues. Dr. Krishnan has produced several research papers. He writes frequently. He talks about climate change quite frequently. He is also the author of the first and the most comprehensive climate change assessment report. He's a co-author. There were other contributors as well. The most authoritative climate change impact assessment over the Indian region. So that's something similar to the IPCC reports that come out every 5 or 6 years, but this is limited to the Indian region. So thanks to that report, now we have a fairly good idea of the kind of impacts that we are likely to see specifically over the Indian subcontinent. Welcome, Dr. Krishnan. Thank you for taking this time out. Thank you for agreeing to do this event and answer our questions as also the questions of the audience. So, as today's discussion is centered around climate change and its impacts, the immediate trigger being the extreme rainfall events that we have witnessed this month itself. At the start of this month, there were lots of very heavy extreme precipitation events, mainly in northern India, Himachal Pradesh, Haryana, Punjab, Delhi, Western UP. And then last week, just about a week ago, we had similar events in Gujarat as well. Right. So we have had these events earlier as well. In fact, since 2013 was when the famous the Uttarakhand disaster happened in Kedarnath, and following that, we have had at least one extreme, major extreme precipitation event every year without fail. There hasn't been a single year that we haven't seen a huge, an abnormal sort of a precipitation event anywhere in the country. So we have had such events in Chennai, in Kerala in 2018, in Jammu and Kashmir, which doesn't usually get flooded. That was a very unusual event in 2014. Also, we have seen repeatedly Bangalore getting flooded, Mumbai getting flooded, Chandigarh getting flooded. So all these events, and together we'll just try to understand from Dr. Krishnan what exactly is happening. The way it is, this discussion is being structured, Dr. Krishnan will make a few opening remarks. He will also, come up. He'll also show a presentation, and then once that is over, it will be open to questions. So then we get into a discussion. Also, to remind all our audience, this particular event, this is brought in association with our partners, Plutus IS, who have been supporting this event for very long. So we really thank Plutus IS for their support. So thank you, and thank you, Dr. Krishnan. I think it's over to you, for your opening remarks. I think you are muted, so you'll have to unmute yourself.
Yeah.
Thank you.
Thank you. Yeah. Good evening, Amitabh, and good evening, all the participants. First of all, I would like to thank Indian Express and Amitabh for this opportunity. And I thought I will make a very short presentation before to give an overall perspective of the heavy rainfall events that is happening. Because it is, of course, we are talking, one is climate change, but there's also a lot of natural variability within the system. And there are various systems, synoptic systems that are producing this type of rainfall. So I thought I will just make a very short presentation before. And you also mentioned about some regions in the northwest India, in the Himachal region, Punjab, as well as the Gujarat region, which received a lot of rainfall this year. So some of the past cases I will touch upon, and what has been our understanding, and what the climate change from a climate change angle, how can we look at it, and those will be my thoughts. So keeping that view in mind, I thought I will make a very short presentation. I have about less than 15 slides, and then we can go later for the discussion. Is that okay?
Sure.
Yeah. So let me share my screen. So is this visible now?
Yeah, it is.
Yeah.
Yes.
Yeah, and I'll also move this to the bottom. Yeah. So this is the title is Extreme Rainfall Events over India, and do these point to climate change? And I think this is a very important question that you are asking. And so I'll just highlight some of the studies in the Indian context, what we have known. And with the observed rainfall data, there were several studies in the past who have they have looked at the rainfall data from the India Met Department, and Goswami et al. That was published in 2006 in Science, and later on Rajivan et al. In 2008 in GRL, and later subsequently Roxy, and several others. I may not be listing all the studies. And all these studies using the observed rainfall over central India, this is a box that is shown. So using the daily rainfall for several years, starting from the 50s up to the 2002, 2003 or onwards, from the daily rainfall, what they noted was they categorized the rainfall in different intensities. Those daily rainfall amounts more than 150 millimeters, as well as rainfall amounts more than 100 millimeters, and ones that are less than 100 millimeters, between 5 to 100 millimeters. So what they found was, and they do it year by year, and this study showed that the frequency count of the rainfall over central India, they do it at grid point by grid point, day by day, for each season by season from June to September, and then they get an yearly count. And when they put this yearly count as in the form of a time series, you can see that the frequency count of the heavy rainfall more than 150 millimeters in this part of central India has increased. They take the central India because this is a kind of the core monsoon zone, where the year-to-year variations in the rainfall are well correlated with the all India rainfall.
It is showing an increasing trend over years, starting from 1950.
That's right. And the same thing for more than rainfall with threshold more than 100 millimeters also show a similar count. And later on, they also noted that the low and moderate events, those numbers have decreased, whereas the very heavy rainfall events that have increased in time.
Okay.
And later on, with the more extended data, Rajivan et al., they used from 1901 to 2001, 2003 or 4, and they found a similar variation in the heavy rainfall, and it also showed intraannual and interdecadal variations. And they also reported that this was very strongly related to the Indian Ocean sea surface temperature, which has also been warming over a period of time. And so observationally, from looking at the statistics of these events, I think there is an increasing trend which suggests that this could have a linkage with climate change, as the climate is warming and the Indian Ocean temperatures are warming. Probably there is a link with these heavy rainfall events, increasing trend of the heavy rainfall events for central India. And globally also, now this is from the observations and also from the models. This is from the 6th assessment report. It was estimated that the projected changes in the extremes, both the temperature extreme and also the heavy precipitation over land areas, they are projected to increase with for every additional increment of global warming. And for example, the hot temperature extremes over land, which happened, these are 10-year events, which happened once in the pre-industrial conditions during 1850 to 1900. So with the present we are at about 1.15 degree warming. So presently that's occurring 2 times what used to occur once. It's occurring 2.8 times more.
This is global, isn't it?
This is globally.
Global.
These are the hot temperature extremes over land.
Yes.
And with further warming with 1.5 degrees, 2 degrees, 4 degrees, these hot extremes are projected to increase.
Right.
Likewise, the heavy precipitation over land is also projected to increase. Presently, with 1 degree warming, it has become 30 times more likely compared to the pre-industrial conditions. And with further warming, this is further projected to increase. And so the extremes, both the temperature and precipitation extremes, as well as heat waves and heavy precipitation, they are projected to increase. This is a very high confidence statement according to the IPCC.
Right.
And why does this happen when we talk about the precipitation increase with the temperature? Because of this is mainly comes because of the temperature dependence on the saturation vapor pressure. So as the temperature starts increasing, the saturation pressure also increases, and this leads to, so the atmosphere, the water vapor in the atmosphere will increase by 6 to 10% per degree warming.
Because of the warming, the water vapor content increases in the atmosphere.
Yeah, exactly. And there is more evaporation from the surface. As the temperature increases, there is more evaporation, both from the oceanic areas and from the land areas. And because of the increased evaporation, the atmosphere can hold more water vapor. The temperature increases. And so one of the direct consequences of this global warming is this water vapor feedback, because of which the frequency of heavy precipitation increases. And typically the precipitation increase, heavy precipitation increase, is also at a similar rate, about 7% per degree warming. So the temperature increase is, so the water vapor increase is at this rate, at about 7% per degree Kelvin. And likewise, the heavy precipitation increase is also projected to increase at about 7% per degree Kelvin.
Yeah. So this is important. Actually, one often gets asked as to why does it rain if it's getting hotter and hotter?
Yeah.
So, I mean, this is the reason.
Yeah. So there's because of the increased evaporation from the ocean surface and from the land, and water holding capacity increases. And when we have also seen this, we had run a very high resolution model, climate model. High resolution meaning about a 35-kilometer zoom over India. And we had done this climate change experiment with and without anthropogenic forcing. And what you can see is the experiment which has all these greenhouse gases, aerosols, and all the anthropogenic changes that have happened. That is shown by this blue line.
So anthropogenic is man-made,
man-made changes, mainly the radiative and also land use, land cover changes. Also the changes in the radiative fluxes due to the greenhouse gases and aerosols are incorporated in this model. And we do find that the heavy precipitation over central India, more than the same region which was shown in the first slide, central India, where rainfall amounts more than 100 millimeter per day, that count, there's a significant increase as compared to the natural run, where we do not have any of this anthropogenic forcing.
So the blue line represents a scenario minus climate change.
Absolutely.
If there was no climate change, that is how it would have, and this is a modeling result.
This is from a modeling. So some
modeling
of this
and the red line is the actual events.
No, blue line is the black line is the actual event.
So black is each. Okay.
Black, and the red brown is the one which shows from the model experiment with the uh, anthropogenic forcing.
Sure.
Mainly the greenhouse gases. So clearly we can see so the models are able to capture, and why we use the high resolution is because if you want this kind of very heavy rainfall, more than 100 millimeters per day, those kind of really heavy intensity, and you want a reasonable count, so high resolution becomes important. So that is the point. But so this is basically a thermodynamical effect. When we say the temperature, as the temperature increases, there is more water vapor in the atmosphere, there is more demand. Because of the increased water vapor, these heavy precipitation events are going to occur. That's more of a thermodynamical effect. But monsoon is a much more complex system where the precipitation and the circulation are very closely linked to each other.
Right.
And this is a picture by Rao in 1981, which shows the distribution of rainfall more than 100 centimeter per season, 100 centimeters. You can see the heavy rainfall aligned along the Western Ghats, over the central and eastern parts of India, the foothills of the Himalayas and the Myanmar coast. And this rainfall is produced by various synoptic systems. It comes in the form of monsoon low pressure systems and the depressions, and also during the initial monsoon onset, there's a formation of a vortex which can produce rainfall. Also phenomena known as the metropospheric cyclones, which usually happen around the region of Gujarat and coastal Maharashtra. They can give enormous amount of rain. And so these various synoptic systems, and we also have this on this within the monsoon season, within the subseasonal time scale, we have this propagation of these cloud bands from the equator towards India, towards the Himalayan region, and they happen on a more low frequency time scale. And so these are so this movement of these cloud bands there, so they can lead to active spells in the monsoon. And when this cloud band movement is restricted, you can also get kind of reduced rainfall, what we call as a break in the monsoon.
The dry phases.
So we have so there are different scales. So we have a large scale monsoon that's being set up initially by the temperature gradient and the pressure gradient. The large scale circulation pattern develops, and then as the moisture build up happens, and the convection develops, we also produce clouds which are going to release a huge amount of as the water vapor condenses, it produces into clouds. It releases latent heating, and the latent heating itself can in turn strengthen the circulation. So
this is how it used to be in around 1980s, pre-climate change.
That's right. And even some of these things we also see even in the present day context as well. So there are multiple scales. So the Indian monsoon should be viewed as a multi-scale interactive phenomena. And it also interacts with the tropical cyclones in the Western Pacific. There's between the monsoon convective activity, the tropical.
And by multi-scale, you mean?
So there are different. So one, we have a large scale, the monsoon, and then we have this low frequency movement of these cloud bands, and we have the synoptic scales, and so there are different scales that are involved taking place during this 4-month period, both in time.
Different kinds of triggers for rainfall. A large phenomenon like the monsoon, but you also have local phenomena over a particular region, and all of them interact with each other, is it?
So the rainfall is an outcome of all these different. When I say scale, it is both in terms of the spatial scale and the temporal scales. So because these synoptic systems are typically a few days, and whereas the low frequency variations are much more longer in time scale. So so that's why. So in short, I call it as a multi-scale interactive phenomena. And the Indian monsoon is also affected by processes happening remotely. For example, the El Nino Southern Oscillation. Very often, many times, this picture shows the All India rainfall time series from 1871 to 2022. And this is the mean rainfall, climatological mean rainfall. This is from IITM and IMD. And so many of these deficit years, you can see deficient monsoon years are because of occur during El Nino years. But there were also deficit monsoons even in the absence of El Nino years. They have also happened. And likewise, many of the wet monsoons have happened when during the cold phase of the end. So what we call as the La Nina, where we have cold sea surface temperature anomalies in the central and eastern Pacific, and very strong trade winds. So this was a paper by Vimal Mishra et al. What they showed was they did a maximum covariance analysis of the rainfall over India and the sea surface temperature over the global region. They find that the first mode of the variability in the rainfall, which has a kind of a deficit rainfall, which shows this in the rainfall, which is shown by this red color over India, is very strongly linked to a El Nino type of pattern.
Right.
And they also talked about the second mode over India, which is linked to the Indian Ocean sea surface temperatures. So this is
the IOD, which is called.
This is not an IOD. I will come to that.
Okay.
This is more like a pattern of rainfall where there is deficit rainfall in the plains of north central India, and whereas slightly increased rainfall in the peninsular India. And this seems to be more like a break-like pattern, the monsoon break-like pattern, and which they link it with the Indian Ocean warming pattern.
Okay.
And this, in fact, showed a trend also in the time series. I'm not going into those details. So the main point I want to highlight is the rainfall variations are linked to variations in the SST in the tropical oceans. That is the main point. And sorry. Okay. There is. Yeah. And also when we look at, just like the ENSO, in the late 90s, there was a discovery of another important mode of variability in the Indian Ocean, known as the Indian Ocean dipole. And during the positive phases of the IOD, like some of the big events like 1961, 1994, and 2019, so normally the sea surface temperature decreases in the eastern Indian Ocean, and there is a warming in the west. And usually the trade winds, southeasterly trade winds off the coast of Sumatra are very strong, and they increase the upwelling in the eastern Indian Ocean. There is more biological productivity, and and then these equatorial easterlies, they produce more downwelling in the west and produce warm sea surface temperature. And so this mode of variability, especially the IODs, what we have seen is like the 1994, 1961, 2019, they were all associated with above normal precipitation over India. And many times over the region of Japan, we have dry summers during this period. And in fact, in one of our earlier studies, we had shown that because of the IOD events, because you have this cold sea surface temperature and high pressure, the high pressure sitting there, so there is outflow at the lower levels, which takes the moisture from this eastern Indian Ocean. It diverges out and it feeds into this region of the monsoon trough. So it leads to continuous rainfall activity in many parts of northern and central India. And whereas maybe this peninsular part, rainfall can be subdued. So generally, this is one of the features. So I'm just mentioning these points just for the benefit of the audience. And this year, this is the latest picture of the sea surface temperature from NOAA, the sea surface temperature anomalies.
This is this year.
This year, currently.
This year, the Pacific Ocean between...
Pacific Ocean, we see the warm temperatures in the Eastern Pacific and also the Central Pacific. And so the warming in the Eastern Pacific is more than 3 degrees warming. And some places, extreme Eastern in Pacific Ocean, it's even more than 4. And now if you see slightly in the western part of the Indian Ocean, there is warming. But in the east, some cold anomalies are developing.
Yes.
Okay. And so we have to see how it is going to. Normally, the El Nino, so whether this is going to develop into an Indian Ocean positive IOD is we have to wait and watch. And some models are indicating that this may also be a positive IOD here.
Right.
But generally that peaks during the September, October months, September,
Yes.
October, November, but it evolves through the monsoon season. And so as the positive IOD evolves, it can also affect the precipitation, the water vapor
Precipitation.
transport
Yeah.
and precipitation over India.
Yes.
And now going back, so I thought I should give a picture of these. So monsoon is affected by these big drivers.
Yeah.
And now when we talk about, you mentioned about the Uttarakhand event. Yeah,
Yes.
it was a very big one. And this we had done an earlier study. And this was the situation. There's a big Shiva statue before the flooding happened. And this is on 20th
Yes.
June. And this
Yeah.
was
It's a
badly,
famous picture. Yes.
famous picture.
Yeah.
And so one thing that happened was at this time, the monsoon onset was rather quick. And the low pressure, by 16th, we had the many low pressure systems, and several studies have shown this, including Professor T.N. Krishnamurthy and many others.
Yeah. Yes.
So there was a buildup of moisture, and there was a low pressure system that moved very quickly from the Bay of Bengal towards this Kedarnath region. And so as the monsoon was intensifying, usually in the lower level, we have the southwesterly flow. And as the convection develops in the monsoon convection builds up, in the upper level, we have a very big anticyclone. So in the meteorological parlance, we call it as the Tibetan anticyclone. And because that's where the outflow in the upper troposphere happens. And this big anticyclonic high pressure, so there's outflow at the upper level. And this was getting very strong because of the intensification of the monsoon system. The anticyclone also in the upper level started intensifying and extending westward. And so as this was getting elongated westward and this anticyclone was intensifying, same time we had a deep trough extending right from the high latitudes, extratropics. Almost it came even north of 60 degrees, 70 degree north. So this deep trough in the mid-troposphere, upper troposphere, even 700 millibar. So this deep trough extending from the high latitudes, it was converging. And then you have this monsoon low pressure system going from the Bay of Bengal. So these two are kind of converging in the lower troposphere, mid-troposphere, over this region of Kedarnath. And there was an influx of moisture from the Bay of Bengal. So this is a synoptic system. You can see low pressure system on 15 June.
Right.
And so the interaction of the monsoon system with the extratropical westerly trough produced large convergence and led to the heavy rainfall.
Right.
This is what we showed. I'm not going into the details. And rainfall daily, this is from one of the observations. Several stations, they received more than one day rainfall exceeded more than 370, 400 millimeters of rain in a day. And this happened for several days and then led to flooding and landslides and so on. It was a major disaster. So that is one point. And probably this year also the heavy rainfall that happened, from what I saw, I looked at the synoptic charts of the NCMR WFIMD. So they all showed this very active monsoon trough, the upper level anticyclone, and we have this deep trough from the mid-latitude westerlies converging. So that was associated with the heavy rainfall for northwest India that you alluded in your earlier presentation. Now coming to the other famous type of systems, what is known as the mid-tropospheric cyclones. So these are typically they form over the region of Gujarat and western Maharashtra and Bombay and many areas. And this was first identified by Miller and Keshav Murthy during the Indian International Ocean Expedition. And these vortices, they generally, the signatures at the surface, you may not see them. And they are almost quasi-stationary. And generally, they can produce very heavy rainfall. And we had done a study earlier in one of our papers. And these are typically the 3-day accumulation amounts can be something like 700 millimeters of 600 millimeters. And so this is typically, and this is an example during 25th June 2006 it happened. And by the way, 2006 was also an IOD year. I just want to mention that. And you can see that this very organized convection extending all the way from India into Burma, Myanmar, and Vietnam, and further eastward into the South China Sea, the Philippines. So it's really a very organized, extending a few thousand kilometers. Within this organized convection, you have these embedded deep convective systems, and you can also see the convective system over the Gujarat region. And so this is associated with this type of metropospheric cyclones, and many times they can be caused because of a low pressure system or a depression forming from the Bay of Bengal, but they can also happen independent of the Bay of Bengal systems.
Yeah.
And so this can lead to heavy rainfall over the Gujarat region. And what we found in our study was we had now with the satellite, the TRIMS precipitation data sets, they have this precipitation radar where they get the three-dimensional structure of the hydrometeors, and you can get the heating structure, how much is the heat, their estimates of the heating, the latent heat of condensation. And what we found was many times the MTCs develop when these organized rain bands, convection bands move northward. And so many of these mesoscale convective systems develop, and the heating is more of a, has a peak around 400 millibar with a strong vertical gradient. And with this type of vertical gradient, which peaks in at 400 millibar, you tend to get convergence in the metropospheric levels and the formation of this metropospheric cyclones. And so so that is why I am alluding this is, you said, of course, these heavy rainfall events in India and Western, they're all increasing. They seem to be slightly increasing, at least the duration. But I want to draw attention to one of an earlier study by Dar et al. He pioneered the study of rainstorms in India. And this was a very famous rainstorm during the 1 to 5 July 1941, which led to heavy rainfall over this west coast, over Surat, Bombay, Pune, and it led to major flooding and a disruption of the traffic. Electricity lines were badly affected, and this was associated with the low pressure Bay of Bengal depression that moved. And some of the stations in this Surat, Navsari, Dharampur, they received very heavy rainfall during this period, and continuously for several days. And so this is one of, they could be associated with MTC. They could be associated also because of the low pressure systems and the monsoon depression from the bay. And so this region, especially the Mumbai and west coast, this southern part of Gujarat and Saurashtra, they can get a lot of rainfall because of this phenomenon. And interestingly, we have made a study. I'm not going into those details. Especially these rainstorms, what we see, which produce a heavy rainfall over Western India, many of them we find that they have been associated with IODs, positive IOD events in the past. Several of them, not all, but quite a few of them.
Right.
And the question is, now there was a paper in 2014 by Venju Cha et al. What they find from the climate models is that the frequency of, as with global warming due to the greenhouse gases, these IOD events could become extreme in the future. And you can have more severe IOD events.
We did see an example in 2019 when the impacts were quite pronounced.
Yeah. So, of course, they're talking this more into the future,
right?
During the later part of the 21st century. And so if the IOD events are going to be affected by this global warming, and they're going to increase in intensity, the amount of water vapor being transported into the monsoon region, and so the development of these heavy precipitation is something which we need to consider. Okay, and the third example I thought I should highlight is the Leh flash floods in 2010, and this was a paper by Rasmussen and House. And because because last year 2022 we had this very heavy rainfall in Indus Valley in Pakistan, which led to major disaster. And before that, in 2010 also there was a big event. and there's a big La Nina in 2010, and 22 was also a La Nina event.
Right.
And so there was heavy precipitation in that part. And immediately after the Pakistan heavy rainfall and flooding of the Indus Basin in July 2010, immediately during the August, there was a very heavy torrential rains prevailed over this Ladakh region. And the town of Leh, which is located in Ladakh, in the state of Jammu and Kashmir, and is a high altitude cold desert valley. It's actually desert kind of conditions, and it's about 3,500 meters above sea level. And the heavy rainfall was delivered by a succession of mesoscale convective systems that moved into that region and led to heavy flooding. I just want to, and this is a the example where the diurnal variation in the convection becomes important. This is what they led to the flash flooding. So these are the maps of the circulation from 3rd August, 4th August, 5th August. You can see the low pressure system forming in this region. The monsoon trough is active. It is strengthening along this region, and there is moisture transport from the bay towards this region of the Tibetan Plateau and also the Ladakh. And what they found from the meteosat data is that these are the imageries from 6Z. This is 6 UTC, 12 UTC, and 20 UTC. So in the later part of the day, they are shown for different days from 3rd August, 4th August, 5th August. So during daytime, when the land is getting heated up, so 12 UTC is around 5:30 p.m. And so by the time the land is, the Tibetan Plateau is getting warmed up, and then you have this moisture coming from this region. And so the land, when it is heated, due to the diurnal changes so these mesoscale convective systems, they start developing and they start moving westward. And so as the moisture goes from the Indian Ocean, from the Bay of Bengal towards the Leh, it can really trigger this very heavy convection. It can make the atmosphere convectively unstable. And so it can trigger this very heavy rainfall. So this is conceptual model. You have the moisture flow from the Bay of Bengal, from the Indian region. And in the Tibetan Plateau, the land is getting heated up. The mesoscale convective systems are forming and they move westward. So as the moisture enters into this region, these very deep convective systems can be triggered and they can produce heavy rainfall and flooding in the slopes of the Himalayas. So the main point is the moisture is a very, very key important factor. So it's not only the thermodynamical effect due to the climate change, but also so many dynamical changes that are associated with circulation changes and the variations in the system. And so with this, I want to just give an overview, I thought. And this is a small advertisement. You mentioned about our book, which we published as a assessment report of the Ministry of Earth Sciences. So this book is it's open access. Everybody can use it freely.
I do refer to it, so that's why I remember.
Thank you very much. So
thank you, Dr. Krishnan. It was almost a small lecture in the class.
Can I stop sharing?
Sure. So thank you. As I said, it was a small lecture in the class on the rainfall patterns in India. So now to start with, let's go back to our original question in the title itself. The recent extreme rainfall events, and we have seen several such events during the month of July. First in northwest India, and then over Gujarat and adjoining parts. So, it's too early to say whether they would be caused by climate change. And I also remember IMD saying that there was a little bit of interaction with monsoon winds interacting with the western disturbances. So there was a little bit of local influence as well. But these kind of, not specifically these rainfall events, but the kind of trends that we are seeing over India, uh, can they be classified as having been caused, induced by climate change?
Yeah, in a statistical sense, as I showed in the first picture, when you look at the heavy rainfall event over central India, where we see an increase in the events more than 150 millimeters per day, and we are seeing that even in the model experiments with the greenhouse gas forcing.
Yeah.
So as compared to the ones, so in general, the statistics of the increase that we are seeing, the trend that
Right.
seen, so that has a link with the climate change. That is what it says. Now, when we are referring to a particular event,
Right.
whether you're talking about this year or Gujarat or Northwest India, this is called the event attribution. We have to
Right.
act whether that particular
Yep.
event is because of climate change.
Yep.
And to do that, normally we have to do these experiments with
Yes.
and without the effect of, and you have to do many ensembles, large ensembles,
Right.
because
Right.
if you want, as I said, there is a natural variability. There is also the effect of the thermodynamical increase in the water vapor and the climate change impact. Now, if you want to separate the two, you want to bring out the signal to noise ratio, you need many ensembles.
Right.
So we call them as large ensemble simulation. And
Right.
that we have to do, then only we'll be able to separate that this is because of the climate change. And you have to do it with respect to each event or something.
Yeah.
Then only.
Yeah.
Yeah.
So I will come to the attribution studies in a bit. Actually, that was one of the things that I had in mind. But I mean, looking at the Indian map, are these kind of extreme rainfall events, are they becoming more likely over the entire region, or do we expect certain regions uh, to get more of these kind of events compared to others, or is the entire country likely to be affected by, uh, I mean, is the distribution of such rainfall events, is it random, or can we pinpoint one particular region as more vulnerable than the others?
I think it's a tough question, actually. Yeah, I think we need to do region by region. There was
Region
one
wise.
earlier study, which showed that extreme event, the trends are not uniform across India. Some
Right.
parts, the rate of increase is different, and in some parts, the trends are different. So it is also spatially, it is not the same.
Right.
Central India, we see some signal, but now if you go to other places, the trend may be very different. And
Right.
as I said, they are all very much dependent. For example, Western India, as I told, these MTCs and farming, they have a link to these IOD events as well. So they can be, so the regional heavy precipitation region wise, it has a link to the circulation pattern. It has links to the modes of variability, the way the water vapor is channeled to that region
Right.
from a source, and so all that is going to decide. So, but yeah, but we can expect that many regions heavy precipitation is projected to increase. So, in a global sense, yes, and
So
even yeah.
which also means that, and we have seen that the overall rainfall in the country, the
Uh-huh.
annual rainfall,
Okay.
it hasn't changed much. We'll
Okay.
over in a year we receive about 1100 something millimeters over the country as a whole.
Okay.
Now that hasn't changed, but
Okay.
within that, what seems to be happening is there would be intense rainfall on small number of days, and then there will be extended dry periods in between, isn't it?
Yeah.
So why does that happen? Why is rainfall not evenly distributed in time as well?
Uh, why it is not? Yeah. Um, yeah, that's a yeah. The one thing is, it also, as I what we see is it also depends on the systems, the weather systems, the monsoon
Right.
systems,
Right.
and when the systems are organizing, and that is the time when you can expect these events to produce a lot of rainfall. And when there is a lack of these systems, monsoon synoptic systems, you see them. So in time, they are not going to be same all through the year. So
Right.
it is very much tied to the circulation, the formation of these systems, monsoon synoptic systems, and others on the subseasonal time scale, the movement of the cloud bands and so on. So that's what I mentioned. So there are different scales that are involved. So
which means that we will have to live with increased uncertainties with regard to these kind of extreme events, isn't it?
Yeah, uncertainties, but at the same time, when we see the early warning systems that have been developed in India from the IMD,
Yeah.
I think we have made a tremendous progress. We had Biparjoy this year.
Yes.
Now all the model forecasts, they did a tremendous job. And I was told that this year, the 48-hour forecast, the track error was 50 kilometers, which is a big improvement compared to the earlier years. And so the models are performing well, especially for tropical cyclones. And also some of these monsoon synoptic systems, active phases of the monsoon, they are doing pretty well. So the development of the early warning, we have to live with it, but at the same time, we need to, the early warning systems have improved. We need to further improve them. And that is going to be the key.
The early warning systems.
Early warning systems, the NWP centers. So numerical weather prediction. Weather prediction is going to take a lot of importance.
Right. Also, I want to understand it very clearly. The linkage of increased precipitation events with climate change or global warming is mainly because of the increase in the evaporation leading up to more presence of more water vapor in the atmosphere. Is it mainly because of that, or are there other interactions at play as well?
Yeah, it is mainly because of the increase in the water holding capacity.
Right.
And also, as the temperature increases, there is more evaporation from the oceans. And but evaporation can also be caused because of if there is more winds blowing over the ocean. They can also, as the wind strengthen, they can also evaporate. It depends on wind speed also.
Right.
So
right.
Yeah.
So I'll come to the attribution studies now. So we know. I remember having seen that 2013 Uttarakhand disaster that was attributed to climate change. I think there was a paper in 2014 or 15 in the U.S. Geological, their magazine, and there was a paper which said the Uttarakhand disaster could be attributed to climate change. After that, we have seen the Chennai floods of 2018. Then I think the Kerala floods were also apparently assessed, but I don't think that question has been finally settled whether Kerala floods, the Kerala rains, were Chennai floods were 2015 and Kerala in 2018. Whether they were because of climate change. So one, I would like to know, if you could tell us, how is that done? How is the attribution done? And why can't all the events be attributed? Does it require a lot of effort? Does it require lots of data? What is involved in these kind of attribution studies? Now, of course, attribution studies, I must tell our audience as well, it's a fairly recent sort of development. It started barely about 20 years ago, and the first attribution studies started happening at the start of this century. And it's only now that they are happening with much more regularity. In fact, in the first decade of this century as well, we've hardly had any attribution studies. But now we see more and more attribution studies coming out. So, sir, how is it done? What kind of effort is required? And why can't all the events be attributed? An attribution study can be done on each of these events.
Yeah. Yeah, see the attribution. So I presume that you are asking about these model-based attributions. Is the doing a model experiment to
Are
using
there other
a
ways as
dynamic.
well? I'm only aware of this one.
Uh,
Are there other ways as well?
Perhaps there are maybe some statistical approaches to
Okay. Okay.
attribute it.
Yeah. Yeah.
It
Yes.
but if you want to do a model-based attribution,
Mhm.
then it depends on, for example, the example I showed about the central India rainfall in a
Yes.
climate change with and
Yes.
without greenhouse gases. We looked at from 1950s to the present
Mhm.
how these heavy rainfall events more than 100 millimeter per day. So that is an attribution study as well, if you might call it.
Right.
Okay. Now, but what we are referring to is a particular event now. Okay, we are talking about Chennai 2015 or that particular event if you want to do, or
Yeah.
Uttarakhand 2013 event.
Yes.
Now,
Yes.
now, as I said, the 2013 Uttarakhand event, there was a low pressure system going from the Bay of
Yeah.
Bengal, and also there was flow of moisture from the Arabian Sea towards that region. And then we had this big anticyclone, big mid-latitude trough interacting with the system. So
Right.
this configuration, you have to, we have with this setup, now we have to do two set of experiment with and without greenhouse gases.
Right.
Okay. With other drivers. Now, if you want, typically we may have to do hundreds of experiments for each of them.
Right.
Okay? And with a fairly high resolution model.
Right.
And that is going to take you some time. It's not that
Yeah.
it is not possible. We start from the same initial conditions,
A lot of computing
and
resources as well.
computing resources. Then we say, okay, I'll make a 10-day forecast. In another experiment, I will make a 10-day only thing with it. But the thing is, greenhouse gases also in a climate context, it is very different. Now here
Right.
we are doing a weather prediction.
Yeah.
Okay. So if you want to change the greenhouse gases and then you want to change, so it has to be cleverly designed. First of all, how to design that experiment
Right.
is to be thought over. Okay.
Yeah.
Now, and but that is possible. In principle, it is possible to be done. But so if you have these resources and when you do this large number of experiments and then analyze that, bring out that signal, it is going to take time. It is not an immediate thing. And by
Right.
the time you do that, you will have another event. Okay.
Yeah.
Then people
Exactly.
will come, what happened, whether this is due to climate change, and we will be just chasing events. Okay.
Right.
Now,
Right.
so the point is probably we have to, so having a wish list of we can have all the events and keep doing that.
Yeah.
But that's good. So we have to probably take a very pragmatic approach. Which are the events we are going to do, and how
Right.
we are going to do that, and what is the strategy.
Right.
But in so that with a coordinated plan, we can do that. If that is the plan, it is possible. And
So
also model to model, there can be differences.
differences.
Okay, and one model may say this. So how are we going to? So we need to coordinate this big effort. And if we can come out, because we are talking about a small region, there is so much of internal variability, and rainfall itself is a tricky business. And
Right.
now when we say the observed rainfall, it's let us say 300, 400 millimeters in a day. Models may not even do that. Okay, they
Right.
may not
Right.
even get a one-day forecast. One of my colleague was telling Kerala, they are nowhere near the actual rainfall in the one-day
Yes.
forecast, even with a 12.5 kilometer global model. Okay.
Right. Right.
So now if I, then one will say that I will take the top 99 percentile and above. So the
Yeah.
question is how you define the extreme also. What do you mean by extreme rainfall?
Right.
So we
Right.
have to have all these protocols defined before itself. And what is the metric we are going to do, and design the same set of experiments, and which are the events, plan them well in, and maybe come out with the assessment. It is possible, but this has to be planned and coordinated properly.
So a rigorous scientific attribution study would require a lot of effort, would require a huge amount of computing resources and also time.
Yes.
And possibly that's why you probably have to choose and select some of the events
Yeah.
uh, with an overall focus on what am I trying to achieve by
Yeah.
doing this kind of
Yeah.
attribution study, isn't it?
That's
So I will ask you the last question before I throw it open for the audience.
yeah.
Uh, uh, the thing is, so apart from extreme rainfall event, the other, of course, very visible sort of impact of climate change has been heat waves as well. We have seen it in India, we see it globally. In fact, we are currently in the midst of what is going to be declared as the hottest ever month. Not just the hottest ever July, but also the hottest ever month. Uh, so heat and extreme rainfall are two very visible impacts of climate change. But over the Indian subcontinent, what are the other kind of impacts that we are likely to see? What are the likely impacts on the coastline, for example? That's one question that someone from the audience also was interested in knowing. What is the sort of impacts that we see on the coastline? What are the other kind of impacts that we can expect over the Indian subcontinent?
Yeah. So that's a good question. Now, if you see the tropical cyclones, especially Arabian Sea, they are becoming more and more frequent.
Frequent.
That is we have seen that earlier mostly it used to be in the Bay of Bengal.
Yeah.
Now Arabian Sea cyclones are becoming, and this year we had.
That's also, a part of it at least has to do with climate change, is it?
It could be. It could be. We cannot rule out that possibility. We
Right.
cannot rule out that possibility. Now, again, it becomes an event attribution. Now, if you want to
Right.
show that this one, we have to do that.
Yeah.
And also, we are making some high resolution runs here to look at, in general, what is happening to the tropical cyclones in the Arabian Sea and Bay of Bengal with climate change. So that some work is going on already here at IITM. But so if the Arabian Sea cyclones are going to increase, they're going to affect the storm surges, and already the sea level has gone up. And one of our colleagues looked at the very high resolution sea level tide gauge data from the Indian region. And
Right.
these extreme sea levels in many coastal areas are increasing. And
Right.
and this is mostly related because of the increase in the mean sea level in the region itself. Once the
Right.
mean sea level increases, and when the storms happen, so the extremes in the sea level coastal regions can experience. That's what we find. And so that could be one of the consequences we can see in terms of the extreme sea levels for the coastal areas. The other thing is with the melting of all these glaciers and in the Himalayan region.
Yeah.
And because they are going to have impact on the water, and when this heavy precipitation happens, like what happened in 2022 in Pakistan, so that
Right.
can be, so the runoff because of the increased melt plus the precipitation, so that could lead to a large amount of runoff and flooding. So it can cause big problems. The snow melt, increased snow melt can also have consequences on flooding. And also urban areas are getting many cities, with so much of the infrastructural development taking place, and drainage, of course, is partly related to management issues as well, not just precipitation. And the sewage system and drainage and all those things. With the heavy precipitation, this flooding is going to become a big issue. These are all the, because it's more of a, it's not just meteorology, that's other hydrological issues involved. And management, governance issues.
Yeah, I will just squeeze in one last question before I go to the audience, and that is about your own report, the assessment report over India, that also points out the warming over the Indian subcontinent is not likely to be as high as the global average, and compared to the rise in land temperatures, actually uh, uh, the warming over the Indian subcontinent is quite significantly lower compared to the warming that is expected over land in the rest of the world. Now, if we have lesser amount of lesser amount of warming over India, what are the consequences? So, number one, very briefly, if you could tell us why that happens, what is the likely reason for the warming over India, which is expected to be slightly lower than the global average, and what are the consequences?
Yeah.
And also the last thing, as someone else also pointed out, is there anything that we can do to stop global warming? or we just have to deal? Do we have to deal with? Are we reconciled to deal with the impacts, or can we, in the short term, can we do something to stop the impacts? So I've asked you three questions. So
Yeah. So the generally when we see the temperature changes, they are most pronounced. The trends are most pronounced in the polar regions.
right.
In the polar
Yeah.
regions.
Yes.
One possible reason could be because of the albedo feedback,
Right.
the ice albedo feedback. The ice is
Yeah.
melting. There is more
Yes.
absorption of the radiation by
Right.
the exposure, water,
Ice,
and
white
land
ice.
surface.
Yeah.
So
Yeah.
that leads to amplified warming in the high latitude region. It is
Right.
also affected by circulation changes, what they call it as
Right.
the Arctic amplification. Once you
Right.
make the changes in the temperature gradient, then
Yeah.
you can
The
increase the
feedback
warming.
loop.
Feedback loop can. So there are feedbacks associated with that. And in general, in the tropical areas, the warming is less
Yeah.
rate of warming compared to the high latitudes. There are
Right.
feedbacks because one thing is the formation of the clouds. The clouds also are going to reduce the radiation coming,
Right.
reaching the surface.
Right.
And so with increased cloudiness, the temperature itself cannot, so the rate of warming can need not be as high as what we see in that is one of the reasons. And of course, the water vapor feedback is going to contribute to the increased
Yeah.
warming. And now, of course, there was some effect of the aerosols that cooled large areas in the northern hemisphere. This is the IPCC assessment. In many parts, you had these emissions from North America, Europe, and especially 70s, 80s, and so on, and China, even India. That has kind of offset because they cut down the incoming solar radiation, and that has also, without that, maybe the temperature increase would have been much higher.
Right.
So but that is over a very large areas of the continental areas. So yeah, so in the tropics, water vapor feedback is one potential reason where the warming could happen.
Right.
But it's a much more complex issue because clouds are there and how the temperature is going to increase. So there are many feedbacks, and then the precipitation is going to happen. And when the precipitation happens, the soil is going to get wet. And again, you may not see the warming. There is going to be more evapotranspiration. The latent heat fluxes are going to happen. So it is going to be complicated. But so very dry areas, maybe some areas in extreme northwest India and the things, there the temperature increase could be high, where the land surface is not wet. And especially during the pre-monsoon months, the temperatures can go up because of the direct heating of the land surface. The temperatures could warm up. But because of so the land surface processes are going to be a very key factor, also controlling the temperature changes over the Indian region. And so with increased monsoon precipitation and overall rest of the year, I think the temperature increase may not be that much. That's my loose. These are my loose thoughts. Yeah.
So
yeah,
I'll invite our audience participants now to ask their questions.
Yeah, of course, the mitigation, how to control,
I forgot. Yeah, can we stop it?
Yeah, so
of course, there's this global effort being made to stop it. So can we stop it in the short term at least?
Short term, I don't know what is it's a very tough question you're asking. So it is all there. I think that's to be done by these developed countries first.
Yeah,
they have to, but it is going to be difficult because these greenhouse gas, they have very long lifetime. So it is going to take a while because even if they start making net zero and all those things,
the emissions,
it is so this
magically stop today. The temperatures are going to continue to rise for some time.
Absolutely. Yeah.
So I'll invite audience participants now to ask their questions. First up is Priyadarshini Karan from Plutus IS. Priyadarshini is a psychologist. Priyadarshini, please go ahead.
Yes. Hello. Good evening.
Hello.
So my question for you is that, to what extent Are the floods in Himachal or North India be considered as a man-made disaster?
Yeah, as
This
the
year,
floods.
no?
Yeah, I think that's a. I don't know if there is an assessment because of the heavy rainfall events that are happening, and there are also many developmental changes that have happened in the
Yep.
over the region. A lot of construction work and big changes in the landscape in that region. So the increase, the floods could have increased. I don't know whether there has been any study to really evaluate this, but there is a that is a good thing. I mean, that is a good point, worthwhile examining if there are some impact assessments that can be done because of these changes in the land use, land cover changes that have taken place, how it has affected the flooding. Uh, I'm I'm not sure if somebody has done. Usually, that comes under what we call is as the impact working group 2. So we normally in the working group 1 we focus on the
I mean,
physical.
that issue was repeatedly came up during Uttarakhand disaster as well. Whether we are worsening the situation due to man-made activities in those areas.
Yeah.
Right. So I'll
so again, if that has to be done, it would be again an event attribution with hydrological models in this case, maybe. And again, the hydrological models have to be very region specific. They have to be calibrated for that particular region, and they're also very sensitive to precipitation, the runoff and stream flow and all those things. So yeah.
I'll now invite Amit Gupta, our next participant, to ask his question. Amit, please go ahead. Amit, are you there? Can you hear me?
Yeah. Good evening.
Yeah, please go ahead. Yeah.
So thank you, Amitabh sir, for this, for curating this session, and Dr. Krishnan for giving your great insights. So I work in skill development and training space, and we train a lot of our youth in refrigeration and air conditioning. So while I train them on to become a good quality technician, so Dr. Krishnan, if you can guide us that what is it that we can. So while we cover some of the refrigerants and all of those things and greenhouse gases, all of those become part of our curriculum, but structured format. So do you, if you can guide us, so because we would be interacting with a lot of youth every year, so if you can give us some insights that we can share with these guys, because they will be spending a significant part of their career in this industry, on what are some of the precautions or some of the things that they can keep in mind while being in this profession.
Yeah. So again, very tricky question. Refrigeration, there is a lot of CFCs which you may be using to cool, and they are also known to be greenhouse gases, and they can have also harmful effects on the ozone. But now I think over a period of time, due to various regulatory norms, there have been some improvements in the ozone hole. There has been recovery, and so I think it is better to increase the awareness about the CFCs, the harmful effects of the environment, and how to reduce those effects. I think increasing that awareness with your team will be helpful. Also about the greenhouse gases, different greenhouse gases, because their influence on the climate, how they are warming. I think increasing that awareness is very, very important. I think many people are already aware, but from an engineering perspective, from a technological firm, I think these practices also, I mean, having some training courses will definitely benefit them, and people can learn from these courses.
Right. Thank you. The next question is from Rahul Raj Meena. Rahul is an assistant professor at a postgraduate college. Rahul, please go ahead.
Good evening, sir.
Good evening. Good
So
evening.
my question is, how the changes in land use and land cover also appear to be reason for the increase in extreme monsoon rainfall, especially its intensity.
Hmm. Yeah, yeah, that's a. These are all very, very important questions. How the land use, land cover changes. See, one thing for the extreme rain. See, basically, when you are changing the land use, land cover, there is an area where there is a lot of, let us say, forest cover, um, and now you are, if you are going to remove that, so all the forest cover and make the land barren, we are basically changing the albedo of that region. So when we have more forest cover, you are absorbing more radiation. Whereas when you are taking out the forest cover, you're reflecting back more your whatever incoming radiation you are going to reflect back, and you are so that is generally not, because if you are going to reflect back into space, you are also going to the, basically the troposphere will be cool, and you will have that has to be compensated by some kind of a subsidence. This was shown with for this typically for the Sahel region,
Right.
because the Sahel area is in a border area where there is some vegetation. And if you are going to take out the vegetation in the Sahel region and you are exposed, you are going to increase the albedo. That is going to reduce precipitation. So this was seen, but now within the Indian context, the situation may be slightly different. But in generally, when you are going to take out the forest cover and make changes in the land use, land cover, so it can lead to less precipitation, which means when the land is going to get heated during the pre-monsoon months, and later on it can also, this condition is very favorable for triggering very heavy deep convection and localized heavy precipitation also when there is a sudden influx of moisture. For example, I showed though that the Leh floods, it was a kind of a cold desert region. One of my slides where the mesoscale, the land gets heated up, there's a diurnal variation in the convection, mesoscale convective systems develop, and they can produce heavy precipitation eventually. So by removing the land cover, by removing the forest cover, you are making the land, you are changing the albedo, so you can easily warm up during the daytimes, and this condition, so diurnal changes in the convective activity can be altered, and you can also have incidences of heavy precipitation. But in general, the precipitation will decrease. This is what my thinking. If you're going to reduce the vegetation cover.
Yeah. And land use changes are actually one of the very, very important components in the climate change conversation.
Yeah.
And also, when you see emissions of a country, usually it's always mentioned whether the amount of emissions is with land use changes or without land use changes. Land use changes actually, as I said, they form a very, very important discussion point in the climate change negotiations.
Absolutely. And actually for the Indian region, there have been various studies. The problem is simulating the monsoon rainfall in the models itself there are many uncertainties.
Yeah.
And rainfall amount, the distribution. So these questions are, what is its impact of this change when I do, what is it? So it's a very tough question, as with the present models that we have, with the biases we have, whether we'll be able to answer satisfactorily. It's a tough question.
Right. So the next question is from Prashant Mohan. Prashant is a data scientist. Prashant, please go ahead.
Yeah, hi. Can you hear me?
Yeah, yes, Prashant.
Yeah, please go ahead.
Yeah, hi.
Please be a little louder, please.
Yeah, thank you very much for this interesting and insightful talk. This question is tangent from the current area of discussion.
Okay.
On an overall, I can understand that the temperature increase causes increase in precipitation capture over the areas, resulting in increased rainfall prevalence. And this is added to by the ocean drivers, monsoon, etc. What may be the cause for the increased prevalence of things like forest fires and heat waves, especially right now we're seeing things in Greece, for example?
Yeah. So forest fires. It depends on many complex things. My understanding, although I have not worked on forest fire, basically I've read some of the reports. So when the land surface becomes very dry, there is less soil moisture. The land and there is continuously high pressure system. There is a kind of sinking motion over that area and high pressure system. It's very conducive for the development of the forest fire. And for example, many times we have forests in the Indonesian region or Australia, and when there is an El Nino event, and because you have this high pressure, less rainfall, and it's very dry, the soil is also very dry. So when it gets heated up, and also it depends on the vegetation, because the kind of trees you have and the oil that comes out of these trees that in the Australian region, they're highly flammable. It can catch fire. And so basically they provide the fuel. So fuel is a very important thing. What kind of fuel you're having? It depends on the, so when there is less rainfall, dryness, high temperatures. So these are all very important conditions, plus the fuel that is available so that there can be fire and which will eventually spread. And so one of the thing is sinking motions. So when you are having long droughts, dry conditions, that is very favorable for the forest fires. And it is also going to be driven by the atmospheric circulation. If you, generally high pressure patterns which are very persistent can produce those type of conditions, and extreme aridity.
Right. Next question from Tushar Shinde. Tushar? Are you there, Tushar? Tushar Shinde?
Yes, good evening. Can you hear me?
Hello, good evening.
Please go ahead. Yeah.
Hello, good evening.
Yes.
Yeah, please go ahead.
Thank you for this important session on this very important topic. So my point is, yes, we all are aware on this, and there is certainly some kind of connection of these heavy rains and these climate change effects, as it is not proved that this is due to the climate change, but we are certainly facing this. And my point is, the developed countries, as I'm a corporate professional, and developed countries are already starting working hard on this by changing targets to the corporates on the country like
Tushar,
us.
can you repeat your
18%
question? You had gone inaudible in between.
Yeah. There was a small break.
Yeah. We were not able to hear you. Can you just repeat your question and be brief?
Yes, my point is, we are just experiencing this climate change, and surely there is some connection of the rise in temperature and the changes in the environment. So my point is, the European countries, the developed countries are closely monitoring this, and they have the stringent targets on the industries, just like emission levels and all these things. And they're just thoroughly following all these things globally. My point is, the country like us in India, where 18% of population is there, there is not as such awareness on this. So, do you think that the awareness, the education, including these topics in education, or it should be increased?
Yeah, actually, it's a. See, I think I won't say I don't know. Awareness is not there. I don't know. See, generally, many of all these emissions of the greenhouse gases it has come from all these developed countries in the past. Okay, so the India per capita emission is much lower when we see.
Yep.
So in the progress to rapid industrialization and development, this has happened, and I think our people have by and large followed very practices which are generally, environmentally friendly. If you go back and see now, of course, they are building these houses with all these glass houses, which is a Western concept. And as one of my professors was telling, now we are moving up the economic ladder, and we can afford ACs, and we will put ACs in our home. And as the temperature increase, we will increase it. And we'll build these beautiful glass houses and trap more heat in that, and increase the global warming. And we have forgot this is a typical Western concept which we have adopted.
Yeah.
So whether it is correct, I don't know. So this is so probably some of our old methods we were better off. And so probably there is awareness, and we also have to promote what is happening. We have to include in our curriculum right from the school and so on. And but to me, more important, I think the water is going to be an important for us more than the temperature. That would be my take. Compare for the west, for the high latitudes, for the mid latitudes, there the temperature increase is a big worry. For us, it is the water, either very heavy precipitation, flooding, or there is no rain, and so we have to be worried about the hydrological consequences. Rain is going to be a very important thing. How to do that will be a big priority. That's what I would put. And of course, we have to also slowly reduce our carbon footprint, reduce our carbon increase from our country, carbon emissions. So we have to follow those things. But we have to, main thing is develop the early warning systems to gear up for these extreme precipitation events. That seems to be, I would put, a higher priority event for us.
Thank you. The next question from Ayush Srivastav. Ayush?
Yes. Good evening.
Yeah, please.
My question is, at what extent dams reservoirs are affecting precipitation locally? And can we conclude that there is a significant part of this in the cloudburst event?
Dams and reservoirs, huh?
Yes.
Okay.
Yeah, and I don't know how it is. See, some studies have shown that irrigation, massive irrigation in various parts of the world, have led to some cooling because of the big irrigation projects. There has been major reservoirs have led to a temperature decrease. This has been shown by some studies. And how it has affected precipitation, again, a tough question, because precipitation, as I said, models have a big challenge. And how it has affected, maybe, I don't know. But definitely the temperature signal, there are some studies which have shown that irrigation has led to a decrease in the temperatures in some parts of, even in some parts of Indian region, North India. There are some studies. And the other thing is, what was that question? Yeah, of course, irrigation, because of the extraction of the groundwater, I think there has been a big depletion in the groundwater level. For irrigation, it has been extensively used. And this has been seen in the GRACE satellite data. Many parts in Punjab and other places, they have too much of groundwater extraction has led to depletion of the groundwater. That is a very clear signal that we are seeing. And yeah.
Right.
And I don't know about cloudburst. It's again a very highly localized event. And yeah.
Right.
So I cannot.
The last question from the audience is from Himanshu Barad. Himanshu, please go ahead.
Hi. Good evening. Thank you, Dr. Krishnan, for an insightful talk. My question is actually related to something which you touched upon your presentation briefly about the Western disturbances. And in more often than not, and in the news reports also, we see that these extreme events have happened due to the Western disturbances. So has the climate change affected the occurrences of Western disturbances more often over the Indian subcontinent?
Yeah, actually, I wouldn't call it Western disturbance. Some people say it is Western disturbance. Western disturbance is typically a phenomenon that happens during the winter months. Yeah. And sometimes it extends until April and May, sometimes up to May. So what is happening, to call something happening in July and things to a Western disturbance, I cannot understand, first of all. Maybe, but what I would say it's a trough in the mid-latitude westerlies. It is not a Western disturbance, according to my understanding. But so when this trough that is very slowly moving in the upper air, and then you have this low pressure system coming, you can have this heavy precipitation. That was my part. And we have done some work on the wintertime Western disturbances. and what is its impact on the precipitation over northwest Himalayas in the winter time. And there are no big changes. Of course, heavy precipitation in northwest India winter time has increased, and what we find is this amplitude of these westerly troughs associated with these western disturbances, they have become stronger. The amplitude has increased. That's what and they extend more southwards. That's what we found in the recent times compared to the past.
Right. Thank you.
Right. Thank you, everyone who asked questions. That brings us to the end of this very informative session. Thank you, Dr. Krishnan. Thanks a lot for your time, for patiently answering all our questions. Thank you for explaining everything here. We would also like to thank our partners, Plutus IAS, for their continued support. Thank you, Plutus IAS. And thanks are due to everyone who came in to listen as well. Our audience, do write to us. You can also go and check out the explained section on the Indian Express website. Go through the newspaper. These kind of explained articles are published on a daily basis in the Indian Express. Do check them out. They are also quite informative, and we have a whole lot of these kind of articles published online as well. Thank you, all of you. Thank you, Dr. Krishnan. Thanks a lot.
Yeah, thank you very much, Mr. Amitabh, and thank you all. I don't know if I answered.
Yeah, you did.
But I did. To the best of my knowledge, I could provide.
Yeah, thank you.
Thank you very much. Thank you.
Right. Thanks.
Thank you. Bye.
Plutus Eyes is starting